Hi there! For this video, we'll be discussing how to divide radicals. So let's go on immediately to our first example. If we have square root of 6 over square root of 3. So like what we did in multiplying radicals, what we do is we simply divide the radicands of each radicals. So we can write this one as the square root of 6 over 3. You know that 6 over 3 is simply 2. And this one out here is the answer. So that's how we divide radicals. Let's go on immediately to our second example. Let's have a cube root of 125 over 16 cube root of 25. In here, observe that we have a radical out here and whole numbers out here. So what we do out here is we split this one when we multiply. So we have out here 8 over 16 times the square root or the cube root of 125 over the cube root of 25. Like how we did a while ago, this one out here will be equal to the cube root of 125 over 25. So simplifying this now, 8 over 16 is simply 1/2 times 125 over 25 is equal to 5. Indeed, we can write this one as this one. Inside, we can write it as 5 cubed over 5 squared. So loss of exponents, simply 5 raised to 3 minus 2 or simply 5 raised to 1 or 5. So we have here the cube root of 5. So simplifying, this one is equal to cube root of 5 over 2. So that is how we deal with dividing radicals with whole numbers in it. So basically we split them up. Let's try this third example. Let's have the fourth root of a raised to 5, b raised to 7, c raised to 6 all over the fourth root of a b squared c raised to 6. So this time, let's try to deal with dividing radicals wherein the radicand are variables. So again, we'll write this one as the fourth root of a raised to 5, b raised to 7, c raised to 6 over a b squared c raised to 6. And from here, it's simply loss of exponents or dividing by a monomial. So a raised to 5 over a, by loss of exponents, we know that this one is equal to a raised to 5 minus 1. B raised to 7 over b squared, on the other hand, we know that this one is equal to b raised to 7 minus 2. And c raised to 6 over c raised to 6 is equal to c raised to 6 minus 6. So basically, we applied the loss of exponents in this way. So this one is equal to the fourth root of a raised to 5 minus 1 is a raised to 4. B raised to 7 minus 2 is b raised to 5. C raised to 6 minus 6 is c raised to 0, or c raised to 0 is simply times 1. So we can remove that 1 out here. And so we have this one. Simplifying further, note that since we have an index of 4 out here, our goal to simplify this one is to extract the variables with exponent of 4. So in this case, a raised to 4 is already good. For b raised to 5, note that we can write b raised to 5 as b raised to 4 times b. So we'll do that one. Oops. So we have here times b raised to 4 times b. So now to simplify this, we can now extract this 2 out here. So we will have, when we bring out the a raised to 4 out of the fourth root, that will be a. When we bring out b raised to 4 out of the fourth root, that will be b. And the one left inside is the fourth root of b. And this one out here is our final answer. So far, our examples are only dealing with dividing radicals with the same indices. What if we have a different? Let's have the cube root of 4 over the fourth root of 2. So how do we deal with this one? Well, the technique is we try to make these indices the same, similar to how we did in multiplying radicals. So, note first that we can write this one as 4 raised to 1 over 3 all over 2 raised to 1 over 4. Now to make this exponents, the denominators, the same, what we can do is we can multiply 4 over 4 out here and 3 over 3 out here. So this one will become 4 raised to 4 over 12 all over 2 raised to 3 over 12. So we now both have a denominator of 12 out. That implies that, going back to the radical form, this will be the 12th root of 4 raised to 4 over the 12th root of 2 cubed. So as you can see, the indices are now the same. So we can now write this one as the 12th root of 4 raised to 4 over 2 cubed. Simplifying this expression inside, we note that 4 is equal to 2 squared. And so 2 squared raised to 4 is equal to 2 raised to 8 by loss of exponents. So this whole expression out here is equal to 2 raised to 8. Now we can now apply loss of exponents out here since we have the same base. We know that the outcome is the 12th root of 2 raised to 8 minus 3, or when simplified, that is 12th root of 2 raised to 5. Or 2 raised to 5 is 32. And this one out here is the answer for this problem. Let's try out this one last example. Let's have the cube root of 2x squared y squared over the square root of xy. So again, the indices are different. So again, we write this one as 2x squared y squared raised to 1 over 3 all over xy raised to 1/2. And what do we multiply to make the denominators out here the same? Well, in here we can multiply 2 over 2, and in here we can multiply 3 over 3. So this one will become 2x squared y squared raised to 2 over 6 all over xy raised to 3 over 6. And so going back in the radical form, this one now is the 6th root of 2x squared y squared, and we square that one all over the 6th root of xy cubed. So since we have already the same indices, we can now combine them. So this one is equal to the 6th root of, let's simplify this one, this expression out here. So basically we multiply this 2, distribute it to each terms. So 2 squared is 4, x squared squared is x raised to 4, y squared squared is y raised to 4, all over, simplifying this, distribute the 3 over x and over y, that will be x cubed and y cubed. And from here, we again apply laws of exponents for these variables with the same base out here. So focusing on this one, x raised to 4 over x cubed, that one is equal to x raised to 4 minus 3 or x, then y raised to 4 over y cubed, that will be y raised to 4 minus 3 or y. And so this one out here is simply equal to the 6th root of 4, x out here, x, and y out here, y. And that one out here is the answer for this one. Now before I end this and leave you with some exercise, I just want to show you one example that we would focus much more in the next video. So what if we have square root of 3 over square root of 9? Applying the same process a while ago, this one is equal to the square root of 3 over 9. Simplify the expression inside. This becomes the square root of 1 over 3. And we can go back to this form, square root of 1 over square root of 3. We know that square root of 1 is equal to 1. So this one is equal to 1 over square root of 3. Now let's focus on 1 over square root of 3. We might say that this one already is the final answer, but actually it's not, since in radicals we don't really want to have a radical in the denominator. So what can we do to remove this radical out here? Well, we can multiply square root of 3 over square root of 3. Doing that, we'll have here in the numerator square root of 3 and square root of 3 times square root of 3 is simply 3. And so the final answer for this one is square root of 3 over 3. This concept out here, multiplying this one and removing the radical in the denominator, is called the concept of rationalization. I hope the spelling is correct. And so we will dive more into this in the next video, since there are many ins and outs in dealing with this concept. So to formally end this, here are 2 exercises that you can work on. First, let's have the 4th root of 32 z raised to 6 y cubed all over the 4th root of 2 z squared y raised to 11, and the next one is the square root of x squared minus 4 all over the square root of x plus 2. So you can work on these 2 exercises, and you can comment down below your answers and solutions to this. So I hope you enjoyed this video and you learned a lot from it. And yep, that's it, and that is all for this video.